Hi viewers, today in chemical reactions microscale experiment series we are going to see Chlor Alkali process. For that we need laminated sheet of paper. Instead of brine we are taking here common salt solution. Then to see that chlorine is liberated, I will be using potassium iodide. That solution also I have prepared and kept it aside. And phenolphthalein we are going to use to know whether sodium chloride is dissociated into sodium and chloride ions. Then we need crocodile clip with two graphite rods, that is pencil leads fixed, and battery. To prevent chlorine escaping, we will be using this petri dish to cover it. So let us begin the experiment. To also see that chlorine is liberated, we will be using a small bit of indicator, that is blue litmus, right? So to begin with, I will make this blue litmus wet by putting a drop of paper, water. So it is now wet. Keep it aside. Then I'll just have a drop of potassium iodide. That is enough. Let me fix this cell to this wire. Keep it ready. Yes, both the electrodes should be in place. Yes, they are in place. We will add a drop of phenolphthalein. Yes, that will only tell you whether sodium chloride undergoes reaction. Now we will, instead of brine that they use in industries, we are using common salt. I'll just add this, a few drops of it. That is enough, I think. Already the reaction has started. We'll cover it so that it does not, chlorine does not escape, right? Yes, now the reaction is going on, and you can just see the pink color where sodium moves towards cathode. Sodium ions combine with hydroxyl ion of water to form sodium hydroxide. Chlorine is released. You can already see the yellow coloration at anode itself. Part of the chlorine has dissolved at anode after formation. Instead of being released as chlorine gas, it has dissolved there. You can now see the change in color of potassium iodide also. It is slightly turning yellow, and after some time you will find a ring of iodine being formed there, because chlorine released displaces iodine from potassium iodide. The blue litmus also is gradually turning red. In a corner it has already turned red in color. Hydrogen released you will not be able to see here actually. Okay, only chlorine you will be able to see. So you logically conclude that hydrogen also is released there. You can also see the anode being corroded by hydrochloric acid. Probably a bit of that chlorine will dissolve in water, and water contains hydrogen ions also. Maybe that is now corroding the carbon rods, and that is getting dissolved there. So that you don't take into account anyway. Now chlorine is released, and that is changing the color of potassium iodide. So this activity can be used to show Chlor Alkali process, displacement reaction, decomposition reaction, and electrolysis. If we have potassium bromide, you can use a drop of potassium bromide also there. Then you will see the brown color there. That will be seen first, then only this color of iodine, because bromine is more reactive than iodine. So reactivity series of non-metals also you can show here. how chlorine is able to displace bromine and as well as iodine. So that also you can use. So one activity, several concepts can be explained. One is electrolysis, decomposition of sodium chloride into sodium and chloride ions, water into hydrogen and hydroxyl ions, then displacement reaction and reactivity series of non-metals. All this will be able to show using this simple activity. I am showing a closer view of the same. You can just see the violet coloration, and you can also see the litmus color is now colorless because chlorine is a bleaching agent. Though it initially changes red, afterwards it bleaches that vegetable color because I have made it out using hibiscus flower, and that is now bleached. And how nicely you can see the ring of iodine being formed here, right? So you can easily use this activity to show even the bleaching action of chlorine.